Happy Holi to everyone. Welcome back to next video in this series. And the next topic is describe zero trust security model. Yes, describe zero trust security model. So we are going to explore this model in this video. So what it is, it's a security framework that operates on the principle of zero trust, which means never trust, always verify. So, this approach assumes that threats could exist both outside and inside the network. If it is your network, threat could be here, threat could be here. So, what we need to do, we need to trust nobody. We need to verify always. So, if request comes from here, we need to verify. If request comes from here, we need to verify. All right, so this approach assumes threats everywhere, leading to the notion that no entity, whether user, device, or system, should be trusted by default. Instead, every access request must be authenticated, authorized, and continuously validated. Now, if you wondering what about the DID, defense in depth, right? We did that in previous video. What about that? We have to learn this framework, right? So don't worry. This zero trust model complements DID. This complements the defense in depth strategy by adding rigorous verification and access controls at every layer. We'll see that in the end once we have a good understanding of zero trust principle and its pillars. In a simple terms, I'll tell you, in a simple terms, in DID or defense in depth, there were multiple layers and we are protecting the layers, right? Protecting the layers. Now, zero trust will tell you how to protect those layers, not from the technology perspective, but from the principle perspective. Like you have to apply the zero trust principle to protect all the layers under defense in depth, right? So what we need to do, we need to understand the principles of zero trust for that. So what are the principles of zero trust? The very first is, as it says, zero trust or don't trust is verify explicitly. So if any request come to your network, if you go with this idea of multiple layers, so maybe it is physical or it's accessing the application or compute, anything, anybody accessing anything, let's put it this way, whether from inside or from outside the network, that needs to verify explicitly. Explicitly means always authenticate and authorized. Always authenticate and then authorize. So always authenticate and authorize, but how? On the basis of all the data points which are available. This is the important point. All the data points available to verify that particular request. Now, what are the data points? It could be if somebody accessing with the help of a laptop, phone, tablet, or anything. Or if you have Intune, you must be aware like the device is compliant. This device is at a particular location if you have conditional access. So all the data points, device health or service, data classification, anything like anything or everything that you have which will help you verify explicitly that particular request, you gotta do that. This is what covers under principle number one. So, no entity is trusted by default, whether if it is coming from inside either, right? We need to verify it. Now, what are the different mechanisms that we could use? We can have like MFA, right? We can have MFA, CA, that is conditional access. We could utilize identity protection. Identity protection will help you because it uses AI to detect suspicious login. So it will verify if it is a suspicious login or not. We could utilize the PIM privileged identity management, just provide just in time access, right? So if the guy do not have the privileged access, this guy will go ahead and request. It will get the access through PIM, and then it will go and perform the task, right? So Defender for identity is also there to help us verify it, whether the request is authentic or not. This is the principle number one, and it is applicable to all layers here also. Any request which needs to be verified. This is one, verify explicitly. Now, the second principle is least privilege access. So, this is something very important. This is least privilege privilege access. Okay, it is like minimize access to reduce risk. So we need to limit user access with just in time and just enough access, or risk based adaptive policies and data protection to protect both data and productivity. So it will help us in many ways. For example, if you are not supposed to get inside the VM, you should not have that right. You should have the minimum right required to perform your task. So the human error is limited here because you don't have the access, so you cannot, even by mistake, delete it or mess around, right? And if your identity is compromised, you do not have any privileged access, then still the compromised ID cannot do anything because you don't have the rights, right? So users, applications, services should get only the minimum permissions they need, and that too for a limited time. This is again most important, limited time. That's the reason of just in time access, or just enough administration, right? So this will reduce the attack surface by limiting the damage from compromised credentials as well. Now this is done with the help of RBAC, right? This is done with the help of privileged identity management, NSGs, because restrict traffic to only necessary services, or storage access policies, or app gateway with web, like any such resource in Azure that help us do the least privilege or only allowed which need to be allowed. And the third principle of zero trust is assume breach. So just like this, we don't trust anything. We are not trusting again. We are, even if nothing is breached, we assume and start looking for it. All right. So this is like always expect attacks and keep looking. Right. So what exactly it means? Well, organizations must assume attackers are already inside the network and design security controls accordingly. So if we assume breach, we have to apply or design security control in such a way that we should have blast radius, minimize the blast radius. Even if something compromised, it could not could not do the lateral movement and could not compromise the other important resources running. So if we go with the assume breach mindset, we will definitely focus on early detection, containment, and response. And we can do all that with the help of MS Defender, right? We have SIEM and Source Solution, which is our Sentinel. It has AI-driven security analytics, proactive hunting, right? Monitoring is an important part of it. Security monitoring, all those things will help us keep digging what is happening in your environment. Sometimes what happens, environment gets compromised and the threat is in a sleeping state, so that maybe it can just compromise the existing data, but during the copy of those data, that particular malware also get copied to the backup. Even the backup is compromised, right? So we have to assume breach and think from the minimum blast radius perspective and keep looking. Even if everything seems hunky dory, you have to keep looking. And there are multiple devices like Sentinel in the market that will help you do the proactive hunting, proactive log digging, and make your environment robust. Now, these are just the principles, right? Three principles of zero trust. So whenever we apply security anywhere, we should have these thing in our mind. So these thing will complement the defense in depth. In defense in depth, we have multiple layers where we are applying the security from the two perspective. Perspective from to secure it, perspective what happened after something happens like compromise. Now protect it from this perspective, and this perspective, wherever we can apply these principles. So, and if we go further into the zero trust, these principles, if we further go into the zero trust, we have six pillars, six foundational security pillars. So it has two things. First, we have three principles, then we have six pillars. Okay, in this framework, what are these pillars? These pillars are nothing but all those things that we keep on talking. Let me show you. Are these six pillars? Let me give you the name and you would have your picture in your mind, and it will help you. Identities, this is first pillar. We have devices that we use inside our office or outside, by which we are accessing our office applications. Then applications itself, then what we have inside the application, data, and where it is running in the infrastructure. Then infrastructure has network. So all these things are actually, if you see, connected to all the layers. Anyways, they call it these six pillars that we need to protect with the help of these principles. So let's go one by. So identities, what are we protecting? Well, we are protecting identities, which is more or less like principal. It could be application, it could be user identity, service account, anything to whom we can give access or permissions. So if we apply these principles, verify explicitly means we need to apply MFA, conditional access kind of things to verify explicitly with all data points to the identities, right? Then least privileged access, we need to apply RBAC to these identities with the minimum permissions. We need to grant temporary admin roles instead of permanent or just in time. If we talk about assume breach, it would be like Microsoft Defender for Identity, which detects compromised accounts, or identity protection like sign on and login attempts, risk based access control. So, all these principles can help us protect the identity as we talked about. That's how they are connected. But this is fundamental and we are just describing. We will get into the detail when we talk about other series of SC like 100, 200, 300, 400, right? So now you're good with the identities. Let's see devices. So what are the devices? Well, any device that we use to access uh, our organization's applications and all, it could be corporate or your own, your personal mobile or your virtual machine or IoT device, anything. So ensuring only trusted, secure device access resources, right? This device access resources, this should be trusted. So if we say verify explicitly, well, if it is end user side, it could be in tune device compliance policies. Check if the device has antivirus security updates or compliant before you provide access to any application. We can apply conditional access, block untrusted devices. If we think from the least privileged access perspective, then endpoint privilege management limits admin rights on devices, defender for endpoint, detect malware before granting access. If we think from the assumed breach perspective, then of course we have MS Defender, right, which monitors unmanaged devices for suspicious activity. We have Sentinel, which alerts if device starts behaving uh, differently. Right, so we can take a simple example here. Let's suppose this is a remote worker tries to log into an outdated personal laptop here, right here. Okay, now this is managed by Azure Intune. So Azure Intune, let's suppose this is managed by Azure Intune. All right, now Azure Intune detects the device lacks security update and blocks the access until it is compliant. So when this guy try to log in here, try to access, this will be blocked. Now, identity is done, device is done, now applications. So what are we protecting? We are protecting any application that belongs to us, we are owning, or like web apps, SaaS application, Office 365, APIs, backend services, those kind of things. So what are we doing? We are preventing unauthorized access or API misuse. If we see from verify explicitly, it is more like if it is on premises, you could use Azure AD, App Proxy, secure on-prem apps with MFA and SSO by integrating Entra ID. Use API management to secure your APIs, right? Apply WAF, you know, to take care from the DDoS. Least privilege, if we see, for example, if you're using managed identities for Azure resources, right, instead of applying the username password right there. So we are utilizing managed identities. First of all, kind of identity we changed, then applying only giving access to that identity to that particular resource and that much access. Application RBAC, right? And IMS Defender for cloud apps and WAF again will help us in assuming breach principle. Assume breach is all about monitoring, proactive measures or hunting, and designing such a way the blast radius is minimum, right? Then data. Another is data. So what are we protecting here? It could be customers' records, intellectual property, financial data, health data, employee private PI data, right? So ensuring data is encrypted, classified, and accessed securely. Azure Purview or Azure AD conditional access, like Azure Purview identifies and classifies sensitive data, and accordingly, the verify explicitly works for the users. Conditional access help us restrict access based on risk. Uh, if we talking about data, then of course SQL auditing and TDE, transparent data encryption, will encrypt it. We do have under least privilege access, Microsoft data loss prevention policies, and there are other mechanisms which will show people the encrypted data if we do not have the access, if the data is classified. And we could use Azure Keyword, which protects the encryption keys. So assume breach, because if breach happened, they cannot get the keys because it is encrypted somewhere in Key Vault. Then Defender for storage detects suspicious file access. right? So in this case, we can take an example like an employee tries to email a spreadsheet with customer credit card numbers. So if it is a spreadsheet and it has customer credit card number in the manner that we have numbers in our credit card like this 444, right? So DLP, which is policies on data loss prevention policies, detects this kind of pattern, uh, sensitive data, and blocks the email to be being sent, right? It will block it. So assume breach. If somebody tried to send this pattern of data, it will DLP will assume breach and it will stop it. It will not let the data go out, right? So that is data. Now infrastructure has like almost everything in our protecting layers we talked about, like VMs, Kubernetes, on-prem servers, DevOps. So preventing misconfigurations and unauthorized access. So how we verify the infrastructure access? We use things like Bastion, RDP, SSH access, just-in-time VM access with the help of Defender, and apply RBAC for least privilege, Azure policy, Defender for cloud, ensure VMs follow the best practices, all are patched and things like that. And container security with Defender for Kubernetes blocks trusted workloads. In assume breach, again, we would have Sentinel, Defender for cloud workloads, which will monitor, detect all the suspicious activity, and you can do all kind of analysis on the logging or monitoring data. So in this situation, let's take an example where a hacker tries to exploit the, let's suppose there is a VM here, right? And here is the RDP port. Now this is a hacker here. So what this is doing, this guy is trying to hack this RDP port. Now, just in time, VM access deny access, preventing the brute force attacks because this is not open for this particular time, and hacker will definitely leave it. Just a silly example, but you got the point, right? Now, finally, network. What are we protecting? We are protecting virtual network, hybrid VPNs, on-prem data center networks. We are preventing data exfiltration, DDoS attacks, and lateral movement, right? So, how we are verifying it? With the help of firewalls, with the help of DDoS protection, so that we can block malicious traffic. Private link, private endpoint keeps the traffic inside Azure network. Uh, Least privilege access with the help of NSG, like network security groups, restrict access to specific IP ranges, zero trust segmentation, isolates workloads based on risk, Defender for network security, and Azure traffic analysis, network watcher, all those things will help us detect suspicious network flows. So that's how we protect the network with the help of all these principles. Now, let's say a malware infected VM starts sending traffic to a suspicious IP. This VM got affected. Now, this guy is sending data to a suspicious IP address on internet. Okay. Now, Azure firewall that we have, this on for from the network perspective, we are saying this Azure firewall will detect it and detect this and block it automatically, right? So assume breach. All those security related resources are active all the time because they are assuming breach is happening, and they stop it, raise alarm, and things happen. Right, so this is all about describe the zero trust security, a very first taste in the zero trust security model. So what is zero trust security model? It has three principles: verify explicitly, least privilege, assume breach, and it has six pillars on which we apply these principles to protect our infrastructure. If you go with defense in depth security approach, both complements each other. You can apply defenses on each and every layer with the help of these principles, right? So with this, let's close the video. I hope it was informative and you guys enjoyed it. Thank you for watching and happy Holi once again.